and I extract the DNA from a banana.
Most of us eat our bananas. Welcome to Left Side of Fashion, your fashion edutainment. In this segment, Eco AF, I, Bun Yan, will be inviting students from around the world to share their kick-ass eco projects. Today, we are going to explore the world's smallest designer. Let me invite my guest of today, Inga.
I myself am a materials engineer. So what I do is I look at everything on a very, very small scale, such a small scale that you, in fact, can't even see what you're looking at. So it's sort of like magic. I change the properties of materials on a micro scale, and you see the difference on a macro scale. So it's super cool, and I really enjoy it. And I'm currently studying at Imperial College.
Oh, wow. That's so cool. How does somebody get into a subject like that? I'm pretty sure little girls, you don't just search material science. That's what I want to be when I grow older. What was that first inspiration?
It's actually quite funny to mention a little girl, because when I was in kindergarten, I was always called the little artist because I was fascinated with color. I came back to university, and when I had an open day, I saw that they changed the color of chocolate from brown to iridescent. So iridescent is all of the colors of the rainbow. And they did it by changing the surface layer of the chocolate. And I was like, wow, this is amazing. This is magic. So I felt like I was going back to being a child. So in fact, it's like, rather than let go of my childlike self, I've gone back to it completely. So I've been looking into bacteria to further understand color. You can have structural color, which means that the material itself intrinsically has a color. Or you can have pigment, such as paint. And what I think is fascinating about bacteria is they can do both. So they can produce both the pigment and they can produce the structural color. Imagine you have a city like London, and if you have many people living together and you look from far away from an airplane, it's going to be a really dark spot on the map. And then if there's only a few houses, it's going to be mostly green, right? Because you can't see the actual houses. Exactly like that picture. So you see mostly green because there's not much people living there. And the same goes for bacteria. Picture here, we see that if the bacteria are closer together, it's like they're closer to their friends, they actually produce a different color based on the distance. And this is what I think is absolutely fascinating about bacteria, is that you can change the color that the entire colony produces only by changing their distance between their neighbors.
Wow. Does it have to do with how light is hitting on a group of culture together?
Exactly. That's exactly it.
Good for money.
What you could think is really cool. I love, by the way, the color of your lipstick. It's blue. You're wearing something that's red intrinsically, because the color of your lipstick is red. So it's absorbing the red wavelength, and we are seeing blue.
Almost like I did this on purpose. There's another type that actually change color, melanins. We see a lot in birds, in their feathers, and we see a lot in sea creatures. In the animal kingdom, that the two groups that's most colorful.
I agree, and that picture is absolutely fascinating. It's a nudibranch. These are these super, super small sea slugs, and you can see them when you go diving. The possibilities of color, and not only color in terms of the wavelength we see, but also fluorescence, phosphorescence. I mean, can you imagine lighting street lights using the bioluminescence of the sea?
That is really, really cool. In fashion, we're already starting to see bioluminescent silk, both combining DNA strand with the silkworm, or taking the DNA out and reproduce it.
I did a little bit of a DNA DIY myself, which I would say you can all do at home, and I extract the DNA from a banana. So it looks a little bit like brains, I have to admit, but I think it's absolutely fascinating that there's so many experiments you can do at home. We're looking at here is in fact what makes a banana. Like, this is as if we'd open up the book of how to make a banana.
You know, Inga, most of us eat our bananas. On another DNA focused TED Talk, that's saying that we're like 70 or 80% similar to a banana DNA. I need to look it up again. Do not quote me, everybody.
Extracting the DNA from the banana, that's only the first step, right? So after that, we start to change the actual DNA, and we can see maybe we can engineer the bacteria or the banana so that the material itself becomes biodegradable, and we can incorporate it to produce bioplastics.
Oh, that's so cool. So essentially, you are putting together the world's smallest designers because you need to use a microscope to see them at work.
I was sitting by the seaside one day in Mumbai, and this girl comes up to me and she says, "Wow, can I see your notebook?" And I'm like, "Yeah, sure." And she starts looking into it, and she's this 13-year-old girl, the girl in the picture, exactly. And she was like, "Oh my gosh, this is amazing." And it was just my notes, and I was absolutely excited to see that this 13-year-old girl thought that my scientific crazy notes were amazing. And so I decided to go back and teach her more and show her what it is I do. An idea would be growing your genes in the lab straight away with the blue. So you no longer even need an indigo dye. It's just directly inside of the material. And I think that's fascinating. And it was lovely to see that she was as excited as me about this.
So let's say the denim jeans is with cotton material. You will be combining it with bacterial characteristics, or combining bacteria with the cotton to produce.
Yeah, so that's an interesting question, because as I said before, there's different ways to achieve color, right? So for example, there's a company, Pili in France, and what they do is they take the bacteria, they ferment them in really big vats, and then they have a dye, and then they put that on the cotton. Another approach would be to directly change the structure of the fibers of the cotton, and so that the cotton itself becomes blue. So depending on the material that you use, it's going to have different strengths. And so when you add these bacteria, you also need to consider the fact that the color you're adding doesn't need to change the properties of the materials, right? Because you still want a stretchy jeans. So if you're going to change the color, that's a really big question, is how to keep the jeans stretchy whilst still changing the color, right?
Now, you discover a lot of these information, the biomimicry, to learn from nature and how to apply it to the modern world from your ocean project, or origami. Please tell us a little bit more about that, other than cleverly putting your name Inga into the name, which is really, really cute. I love that.
Origami, it's a platform which I started actually by going to Indonesia. So when I went diving, conservation diving, it was the first time I'd ever gone diving. And I got many people to sponsor me from Belgium, which I'm still super thankful for. That was an amazing inspiration and startup to this project, which has now been ongoing for 2 years. And so when I first started it, I went to Indonesia, I went diving, and I saw the color of all these corals. And in fact, I love the fact that you have a picture behind you of the color of the corals. And I too have a coral with me, except my coral, as you may see, is white. Inside of corals, there live these tiny bacteria. They're called polyps. But nowadays, because the oceans are warming and there's a lot of plastic going into the ocean, and the pH, so the water is becoming more acidic, the polyps inside, these tiny bacteria that live happily inside the coral, have been pushed away from the coral, and the coral has died. And so this is a really, really big issue, is that we see now dead corals like this one are being washed up on the shores of Indonesia, which, by the way, I did not touch corals when I went diving. Absolutely not. The color of the coral comes from the bacteria inside of the coral. So we need those bacteria for color in coral, but also to make the corals happy and to make them be able to survive underwater.
Yeah, corals are actually animals. They are symbiotic together with bacteria to able to breed, feed, and grow.
If you actually go diving in the Red Sea, there's corals which live more than 50 to 100 meters in depth below the sea. Yet they too still have these fascinating colors, and they even fluoresce. So this is really amazing, because you'd say, well, maybe the corals at the surface, they fluoresce. Now this is a really big issue, right? We see these fluorescent corals, purple, yellow, blue in Australia, and this is the moment before they're dying. But that's not always the case, because these corals in the Red Sea, which are 100 meters in depth, they are also fluorescing in all these colors, and it's like a sunscreen. So they actually try to absorb the sun thanks to these bacteria.
Oh wow, there's so many aspects. We can dive into that. Can go the route of actually growing material, can go to the route changing properties, can go to the route changing colors. It must be fascinating doing what you do every day.
I think the one which was absolutely fascinating was your episode on plastics. It's such a smart way to inform people of such a big issue, but it's so creative. I love it. I absolutely do.
Yeah, I'm really focusing on not to scare more people. I think we are living in a world with a lot of fear, a lot of doubts already. Just like you, I love showing the fascinating side of what excites me instead of just going like, we're killing everything. Anybody you would like to shout out?
Two super innovative female scientists also. Well, one's from doing arts is Shanil Malik, and she started to make algae tiles that she creating in India, and they clean the air whilst just using algae. So I think that's absolutely fascinating as a material and also as an idea. And then the second shout out is to Hansa Shri. I believe she just got a really big grant from United Nations because she's producing pads that are low cost yet very absorbent for females who do not have access to hygienic sanitation. So she's really doing an amazing job as well.
Wow, there's so many projects like among students that we just don't know about. For today, what we learned is you can be the smallest thing and make a big difference, and we can all be eco as